Are you excited to know about what the past images of Venus have revealed? As we know, Venus is one of the most mysterious planets in our solar system. It has been a topic of curiosity for many astronomers and space enthusiasts. With technology advancing daily, we now have the opportunity to disclose secrets through old captured data, which was impossible before. That's precisely the case with the images captured by NASA's Magellan spacecraft, which journeyed to Venus over 3 decades ago. If you're interested in delving further into the mysteries of the cosmos and eager to learn more about our exploration of Venus, don't forget to subscribe to our YouTube channel and share our content. Let's explore together what these images revealed about Venus. Venus has been a subject of interest in astronomy for centuries. Its proximity to Earth and its bright appearance in the night sky have made it an easy target for observations. Over 3 decades ago, NASA's Magellan spacecraft embarked on a journey to Venus, capturing images that have been instrumental in our understanding of the planet. The primary focus back then was to map the planet's surface and study its dense atmosphere. Still, unbeknownst to the scientists at the time, they were capturing something far more extraordinary. These images, taken 3 decades ago, led to a fantastic discovery beneath Venus's dense, poisonous clouds: the existence of active volcanoes. This groundbreaking revelation significantly alters our understanding of Venus and other planets in our solar system and beyond. Venus is the second planet from the Sun. Known as Earth's evil twin due to its similar size and composition, despite the parallels, Venus is a planet of extremes. It's almost the same size as Earth, with a diameter of about 7,521 miles, but orbits much closer to the Sun, with an average distance of about 67 million miles, roughly 18% closer than Earth. This proximity gives Venus a scorching environment, with surface temperatures reaching an incredible 880 degrees Fahrenheit, making it the hottest planet in our solar system, hotter even than Mercury, which is closer to the Sun. Venus's high temperatures can be attributed to its dense atmosphere, predominantly composed of carbon dioxide and nitrogen. This dense atmosphere creates a potent greenhouse effect, trapping heat and pushing temperatures upward. Furthermore, dense clouds of sulfuric acid enveloping the planet contribute to its intense heating. Despite its harsh conditions, Venus has intrigued scientists who aim to understand its unique characteristics and history. Over time, several discoveries about Venus have come to light. For instance, it's the only planet in our solar system that rotates clockwise on its axis. The atmosphere of Venus is dominated by the rapid rotation of the cloud layer, which rotates much faster than the planet itself. This layer completes a rotation in just 4 Earth days, while the planet takes a leisurely 243 days to complete a full rotation. Intriguingly, both rotations occur in a retrograde direction, contrary to the norms of the solar system. For Venus, this means the planet and its atmosphere move in a direction opposite to the Sun's rotation, and most other planets in our solar system. This natural convective motion, known as superrotation, starts at about 6 miles and accelerates up to 40 miles, where equatorial winds reach a staggering speed of 335 miles per hour, gradually decelerating as they ascend to higher altitudes. Despite the unforgiving heat and brutal environmental conditions, the surface temperature of Venus remains almost uniformly constant, courtesy of winds that carry heat evenly across the surface. The Venusian nights, which last nearly 58 Earth days, witness only a slight dip in surface temperature. However, temperature variations are more noticeable with altitude changes. At an altitude of 62 miles, the temperature can swing from a high of 81 degrees Fahrenheit during the day to a frigid negative 225 degrees Fahrenheit at night. Venus's atmosphere is colossal, weighing more than 100 times that of Earth's. The enormous mass of Venus's atmosphere also has considerable thermal inertia, accounting for the uniform temperature on the planet's surface, similar to Earth's oceans. This dense atmosphere, with a density about 1/10 that of water and its corrosive composition, causes erosion akin to a river. Surprisingly, surface wind speeds on Venus are minimal, barely surpassing a few miles per hour, with stronger winds near the equator and weaker ones towards the poles. These winds form a visible V-shaped structure in cloud layer images. Despite these discoveries, much of Venus's early history remains enigmatic. Although we know Venus was formed around 4.5 billion years ago, the processes that shaped it into today's hostile world are unclear. There is speculation among the scientific community that volcanic activities might have shaped Venus's environment, with eruptions releasing gases that formed the dense atmosphere. Observations of Venus have been made across centuries, from ancient astronomers like Greek philosopher Pythagoras and Roman poet Ovid to more recent studies using spacecraft in the 20th century. In 1961, the first space probe to approach Venus, Venera 1, was launched by the Soviet Union. Despite failing to land on Venus, it gathered significant information regarding the planet's magnetic field and radiation environment. Further missions, including the Soviet Union's Venera and Vega projects and the US's Mariner and Magellan projects, added to our understanding of Venus. However, the planet's dense atmosphere and harsh conditions have made comprehensive study difficult. The Venera 13 landing module from the Soviet Union, which successfully touched on Venus in 1982, lasted 2 hours before succumbing to extreme heat and pressure. The Magellan spacecraft from NASA reached Venus in 1990, spending 4 years mapping the surface with radar and gathering a wealth of data, including detailed images and information on its topography, gravity, and magnetic fields. Fast forward to 2021, and scientists made a remarkable discovery by re-examining the data gathered by Magellan. Active volcanoes on Venus were unearthed by a team led by Anna Gilcher from the Institute of Geophysics at the Swiss Federal Institute of Technology in Zurich. By analyzing the radar data from Magellan, the researchers identified surface features indicative of recent volcanic activity. They also examined images captured by the spacecraft, revealing evidence of lava flows and other volcanic features. The question remains how scientists could discern the presence of active volcanoes from data over 30 years old. The answer lies in applying new imaging techniques and algorithms, allowing the research team to extract more intricate details from the Magellan data. In a groundbreaking study conducted in March of the current year, Robert R. Herrick from the Geophysical Institute, University of Alaska, Fairbanks, and Scott Hensley from the Jet Propulsion Laboratory, California Institute of Technology, examined volcanic activity on Venus. In a scientific publication, they described how volcanic activities have remained cloaked due to unobserved eruptions. They utilized images from the Magellan spacecraft taken between 1990 and 1992 to scrutinize volcanic regions on Venus. A meticulous exploration was conducted in areas previously marked as potential indications of active volcanism. The researchers sought volcanic formations such as cones, vents, and lava flows that appeared or changed between images to construct a detailed topographic map, leveraging a technique known as stereoradiogrametry. In addition, orthogonal transformation was applied to make images appear as if they were captured directly over the object under observation. As a result, they ascertained that the vent of a volcano in the Atla Regio region had undergone dramatic changes in less than a year, with the opening doubling in size and deformations observed, and a lava lake filling the edge 8 months later. This finding may shed light on the progression of Venus and the distinctions between its landscapes and those of Earth. As initially presumed, the surface of Venus, like Earth's, had water, but the existence of active volcanism remains uncertain. Despite the scanty study of the surface area of Venus due to missing and poor data, the recent identification of active volcanoes on Venus represents a significant milestone in planetary science. It challenges the widespread perception of Venus as a geologically inert planet, suggesting the possibility of microbial life, similar to Earth, where volcanic activity is frequently associated with microbial life. The discovery has sparked considerable interest in future missions such as the Veritas and Da Vinci Plus missions. The Veritas mission, led by NASA's Jet Propulsion Laboratory, aims to launch an examination of Venus from its surface to its core within the next decade, using state-of-the-art synthetic aperture radar and a near-infrared spectrometer. On the other hand, the Da Vinci Plus mission is designed to study Venus's atmosphere and geology. The Veritas orbiter will circle Venus and collect data from above, while the Da Vinci descending sphere will pass through Venus's atmosphere to study its composition, clouds, winds, and surface features. Regrettably, the last 3 decades have seen a shortage of missions to Venus. This is primarily attributed to reductions in funding for planetary exploration, pushing the commencement of new Venus expeditions into the 2030s. Nonetheless, each novel discovery inches us closer to deciphering the mechanisms that sculpted our home planet, Earth. The unearthing of active volcanoes on Venus represents merely the forefront of what could be a vast array of yet-to-be-uncovered astronomical phenomena. This discovery underscores the formidable complexity and significance of scrutinizing historical data and alerts us to the potential wealth of other hidden revelations waiting to be decoded. It's crucial to acknowledge that until recently, we lacked the sophisticated tools required for processing and comparing copious amounts of data. This advent opens a wide avenue for astronomy and planetary science enthusiasts to delve into research and make groundbreaking discoveries, even without the need for expensive apparatus. The sector is thus accessible to anyone armed with tenacity, dedication, and a thirst for knowledge, highlighting that each individual has the potential to make momentous contributions to this field. So don't miss out on the opportunity to journey with us through the cosmos. Hit that subscribe button now.